This... I shoot a lot of time-lapse photography, especially night time-lapse photography, and I use a Nikon or a Nikon. I use a Nikon Z6 or Z6, and the battery lasts a fairly long time for normal time-lapse, but when you're shooting time-lapse photography at night, they tend to be a lot, the battery tends to go dead a lot quicker because the shutter duration is normally in the 20 or 10 to 20 seconds per shot. So over a whole night, it definitely won't make it on one charge. And if you're in a place where you can leave the camera unattended, you don't really want to have to change the battery during the night and restart the whole sequence. So I purchased myself one of these things. It's not expensive. And how that works is it plugs into this power brick here, and it powers the battery from AC power. So you have unlimited battery essentially. And this is just basically empty, and it just plugs into the normal battery slot of the Nikon battery. And the Nikon needs 9 volts, and it needs an incredible amount of current. So I thought, not a problem. What I'm going to do is I want this to be portable. So I wanted to run off LiPo batteries or anything like that. So I said, cool, no issue. I can take one of these jelly bean converters that you can buy on the internet, set it for 9 volts, and then it can run all the time, and I can just run it off batteries or whatever power source I happen to have lying around. I actually want to run it off a USB power bank, but that's 5 volts. I didn't want to make a buck converter, and I was like, okay, cool, let's just use LiPo batteries. I have a lot of them lying around from the drones and stuff, so that would be cool. Now, when I connected this up, what happened was when the shutter closed, it would just cut out, and I connected to the oscilloscope, and sadly it turns out that it just doesn't supply the amount of current. If you look at the AC adapter here and you look at the output, if it focuses, there you go, the output is 9 volts at 4.5 amps. That's a lot of amps. So it has bursts which are quite high. It's not 4.5 amps, but it's pretty high. So I needed to find a better solution to that, and step in the beautiful linear regulator. It's a $1 or €1 or €1 part, and very easy to find, and I will show you how to make it. And if it works, then we can test it. Here are the voltage regulators in question. This one is a 70L7809CV. That's up to 1 amp, and this one's up to 1.5 amps. The thing is that the power supply doesn't need to supply that all the time. It's not like the camera would run that high constantly, so we don't really need all that much current. And I will go for the bigger one, the 1.5 amps, just to have a bit of extra headroom. The circuit is incredibly simple. Let me draw it for you. We have an input, microfarads. Let's build this up on a breadboard. It's beautiful. I'll probably just be able to overlay a circuit which would look a bit better than this, but that's basically it. So let's just pop this on a breadboard and test it out. Basically you have input on the left, common in the middle, and output on the right. So let's go input here, and we put our capacitor on that. There's a 220 microfarad capacitor. There. We pop that between the input and the minus. As for the diagram, Then we put our lead, that's our input lead, this guy. Then we need another capacitor. It's not that important. I'm going to go with 47. Let's put that here. That's also between our output and our common. It's our negative. Like that. Our common is the middle pin, and the rightmost pin is the output. So you have input plus 9 or 12 to 35 volts and output in this little plug here. So let's set this up. Alright, so here we have our bench power supply set to 15 volts, kind of like a lipo battery, and the meter is just going to measure the output of our little circuit here. So I'm going to turn this on. There's 15 volts here, and if I now measure on the output, beautiful 9 volts, there you go, 9.02. The nice thing about linear regulators is that they are they don't fluctuate much at all. They're very, very stable, which is important for camera, I guess. And also these other circuits that I mentioned before, these cheap things that you can buy off AliExpress or whatever, these guys, these modules, they once the battery voltage drops lower than the point, they often spike up to 35 volts or more. So I wouldn't trust my camera to having something like that. The thing about linear regulators is the voltage that gets output and the voltage that gets input has to be dissipated as heat. So there's quite a few watts that have to be dissipated. So we'll have to see how efficient it is, and through the magic of having made one and being run, and the camera being run off it this whole time while I've been talking, I know what the efficiency is. So let's take a look at that. Here is the circuit I put together first. The only thing I added here is a light and a giant heatsink because it's really hot. So here's the input voltage. It's coming from the battery. It's exactly what I wanted. So this is a 4S LiPo battery. Here I'm just added the cell meter to see what the voltage is. I don't want it to over discharge, and I also want to know how long it lasts. And here is the little circuit that powers it. I put a little switch on the end, a little plug, sorry. And there is the circuit. It's compact, small, efficient, and it's been running this camera the whole time. The camera shows as having a full battery charge, of course, because it's 9 volts, so it is its full charge. And we can see here, let's grab a here I've got a clamp meter. Okay, if I turn it off, it's obviously going to cut the camera off. 1 second.